Hi-de-ho, everyone. Today we're going to be looking at Unit 4, Lesson 2, parallelograms. So we have a vocabulary word right here, parallelograms. Look back at your vocabulary for the definition. Then we have a brief overview of what a parallelogram is. We have opposite sides being parallel to each other. We use this symbol right here to represent a parallelogram when we're writing it. We have some theorems. So let's take a look at the theorems for the parallelogram. So we have theorem 2.3, we have theorem 2.4, theorem 2.5, and theorem 2.6. So theorem 2.3, if a quadrilateral is a parallelogram, then its opposite sides are congruent. If a quadrilateral is a parallelogram, then its opposite angles are congruent. If a quadrilateral is a parallelogram, then its consecutive angles are supplementary, adding to 180 degrees. And if a parallelogram has one right angle, then it has four right angles. That's kind of piggybacking on theorem 2.4 right there. So use properties of parallelograms to find CD. So we want to find this right here. So given what we know about parallelograms from those four theorems above, we know that the line segment CD is going to be congruent to the line segment AB because opposite sides of parallelograms are congruent. Well, if that's true, then the length of CD equals the length of AB. And we know what AB is. AB is 4. So that means CD is going to equal 4. All right, let's take a look at the next one. So proof using the properties of parallelograms. So we want to write a proof, so a nice little 2-column proof, that given parallelogram HJKP and parallelogram PKLM, we want to prove that line segment HJ is congruent to line segment ML. So with these, we always start off with our given statement. So let's write down our given statement. Our given statement is that the parallelogram HJKP and the parallelogram PKLM. Again, this is given. So since that's given, we know that opposite sides of the parallelogram are consecutive. So what are our opposite sides? Well, HJ is going to be congruent to opposite HJ is PK. And we also know that PK is congruent to opposite of PK is ML. And again, this is opposite sides of parallelograms. I'm going to use the symbols here, are congruent. Well, if we know that HJ is congruent to PK and PK is congruent to ML, then we know by the transitive property HJ is going to be congruent to ML. And again, that's the transitive property. And we've proven what we want to prove. And what the transitive property is talking about, we've seen it before, is if they're both equal to the same thing, then they're going to be equal to each other. Think about a height. If you have 3 boys, the first boy is equal to the second boy's height. The third boy is equal to the second boy's height. Well, since they're both equal to the second boy's height, the first and the third boy are going to have the same height. That's kind of what we're talking about here. PK is kind of like our connector. They're both congruent to PK, so since they're both congruent to PK, they're going to be congruent to each other. Let's take a look at a couple more theorems. So theorem 2.7, if a quadrilateral is a parallelogram, then its diagonal bisects each other. And if a quadrilateral is a parallelogram, then the diagonal separates the parallelogram into two congruent triangles. So we're going to use that to help us figure out example 3. So we want to find the value of x and z in the parallelogram ABCD. We know that the measure of angle ADC is equal to 4x, and the measure of angle DAB is equal to 2x minus 6. So let's start off with finding x. So we're going to use those angles. And we're going to use that idea that we have that the parallelograms creates two congruent triangles. So find x, and we want to find z. So we have ADC, so that's right here, ADC, and we have DAB, so ADC and DAB. So going back to that theorem at the beginning, theorem 2.5, if a quadrilateral is a parallelogram, then its consecutive angles are supplementary. So these are consecutive angles, one after the other. So that means they're going to be supplementary. So we have 4x plus 2x minus 6. Supplementary means they add to 180 degrees. Equals 180 degrees. So now we can solve it. 4x and 2x gives you 6x minus 6 equals 180 degrees. Plus 6 gives you 6x equals 180 degrees. Divide by 6. Sorry, not 180, 186 degrees. Gives you x equals 31. Now we want to find z. It's an ugly z. Find z. Better. So we have that this is a parallelogram, and since we know that this is a parallelogram, then we know that we're going to have that this side is equal to this side because of previous theorem. So we have that AE is congruent to CE. So that's going to tell us that 3z minus 4 equals z plus 5. Get z on one side, so minus z gives me 2z minus 4 equals 5 plus 4. Bring this up here. Gives me 2z equals 9. Divide by 2. I get z equals 4.5. So we solved it out. X is equal to 31 and z equals 4.5. So review through these theorems that we were introduced to in this section. So theorem 2.3 through theorem 2.8. You're going to write a summary of what we covered in this section, and then you're going to use these examples to help you answer the practice problems for this section.